Greetings. Welcome to CS320, Advanced Object-Oriented Programming, the continuation or extension of 220, Object-Oriented Programming. And as everyone knows, that we will be utilizing Java in order to extend this discussion or the deep dive into object-oriented programming. So what I'm going to do, I think probably more effective, well, the assumption, you'll see this again in the talking points, but the assumption is that you have the basics of object-oriented programming using Java down pat. Okay, so we'll be basically extending the idea of what you can do with OOP from an advanced perspective under that assumption that you know Java. And I'm sure that everyone in here should be covered, but if not, you'll be able to pick up pretty easily the kind of the fundamental items of Java and the fundamentals of object-oriented programming in order to kind of fall in line with the advanced portion of it. So just let's go ahead and get started. What we're going to be doing in week 1 with advanced OOP. I just want to go through the overviews of the unit. Okay, the unit is going to deepen your understanding of type-safe abstraction. You'll be deep diving into what that means. So, but I'm just going to name it here and kind of lay it out there that anything here that you don't understand, you will understand by the time the end of the 7 weeks. Okay, so there deepens the student's understanding of type-safe abstraction, reusable class designs in Java, through an advanced explanation of generics. We will get heavily into generics, what they are, what they do, why use them. Okay, students move beyond the basic parameters, access to examine bold-type parameters. We'll be examining bold-type parameters, wildcards, generic interfaces, strong emphasis on design intent and application programming correctness. By the end of the unit, you'll be able to design flexible, reusable, type-safe components that integrate cleanly with Java's collection framework. And we'll deep dive into what that framework looks like. While avoiding common pitfalls, raw types, unsafe casts, overly rigid class hierarchies, the unit emphasizes why generics are used, not just how, preparing the students to write professional grade libraries and frameworks. This unit establishes design principles that will carry forward throughout the course, including separation of concerns, compile type safety, and application programming interface clarity. Kind of a highlight during this week 1, we're going to design and implement generic classes and methods, apply bounded type parameters to enforce constraints, use wildcards where appropriate for flexible APIs, implement and use generic interfaces, analyze Java's generic collection at a deeper level, design reusable type-safe, design reusable type-safe modules and APIs, avoid common generic pitfalls. Where does this position in the course? This builds on your core OOP concepts. The concepts of inheritance, polymorphism, interfaces, all of which we've had before in the initial class, and then we're going to be extending those capabilities with the advanced class. So it prepares you for advanced data structures, design patterns, framework level programming, and multi-module project architecture later that we're going to be delving into in the course. Okay, week 1. Okay, in week 2, sometimes this thing is faster than the speeding bullet. Okay, so in week 2, in week 2, just kind of, you'll see me kind of pause out every once in a while, waiting for the screen to come back. So Okay, but in week 2, we're going to be talking about collections framework, mastery, data structures. In this unit, we're going to do a deep dive exploration into the Java collections framework. What's in it? What is the bias? Why use it? We'll be talking about all that with emphasis on behavior. How is my application? How should it behave? What are the performance criteria do I want? And how does the collection framework help me in performance? And design trade-offs. If I do it this way, I'm going to get this type of performance. If I use it another way, it's going to be another type of performance. So again, looking at that framework, these 3 items we're going to be looking at to how do we put those in the most efficient manner. You're going to move beyond basic usage to analyze how different collection types have internally, how they scale, how they design, how design decisions affect their correctness, efficiency in real-world systems. You'll be able to examine core collection interfaces. We'll get into each one of these individually and evaluate concrete implementations based on ordering, duplication rules, lookup performance, and performance characteristics. Not too overwhelming. They'll become common terminology here in the not too distant future. Special attention is given to hash-based collections, including correct implementations of hash code and equal and consequence for violating contracts. Contracts are basically rules that you need to go by to make sure that everything works okay. We'll be introducing the big O reasoning in practical terms. What does that mean? What is the bias with the big O terminology and collections? Justify collection choices based on expected data size, access patterns. Iterators are examined, mechanism for safe travel, transversal, okay, not travel, transversal and modification, reinforcing correct concurrent modification practices. By the end of the unit, you will be able to design scalable, maintainable, performance aware, okay? So we're looking at taking into consideration these things. So how do I use Java to program in order to make sure that I can affect performance, I can affect scalability, I can affect maintainability. So we'll be doing a deep dive into that. So my learning objectives for you will be to differentiate among core collection interfaces, evaluate concrete collection implementations, apply hashing and equality correctly, apply big O reasoning, use iterators safely, design scalable collection-based systems, and recognize common collection misuse patterns. So that's what will be coming out into week 2. How does this position with the cores? It builds on the generics that we talked about previously, and reusable API designs from week 1. It will prepare you for advanced data structures, concurrent collections, design patterns that rely on computation and aggregation, large-scale multi-module Java applications. When you get into the big, huge systems that you'll be using in Java, this particular section is going to prepare you for being able to design and run efficient systems. Okay, that's week 2 and week 3. Okay, in week 3, the unit is going to introduce you to functional programming concepts in Java and kind of introduce you to streams API, Lambda expressions, method references. And again, don't get bent out of shape right now with terminology that, oh, well, I don't know what a Lambda expression is. Yeah, all of that's going to be coming as we go in through the various weeks. And it's week 3, by the end of the week 3, you're going to become an expert on that. Okay, so students, you will learn Java functional features, integrate with collection framework to enable declarative, expressive, and parallelizable, okay, doing things concurrently, data processing pipelines. So you can have one pipeline doing one thing, another pipeline doing another thing, and they're doing them at the same time in Java. We're going to have an emphasis on how streams work internally, the distinction between intermediate and terminal operations, what is that bias, what it doesn't bias. The unit also deepens student understanding of lambda expressions. We kind of mentioned that before. This gives more detail in what are we talking about when we start using lambda expressions. We're doing that by exploring custom functional interfaces, scope, variable capture, advanced use cases such as composition, higher order functions. You'll be able to analyze function approaches and improve clarity and scalability. Which function approach should I use in order to get to the particular, whether it's clarity or scalability or maintainability? What do I need to use in order to ensure that? Okay, by the end of the unit, you'll be able to design clean, efficient, and maintainable stream-based solutions. Okay, so our learning objectives coming out of week 3, examining functional programming concepts applied in Java, use Lambda expressions effectively, design use of custom functional interfaces, build streams, pipelines for stream APIs, understand stream execution and behavior, reasons about performance and side effects, integrate data streams with existing collections, design scalable, readable, and data processing solutions. How do I design this? We're kind of moving, you think of it as we were basically concentrating on syntax and writing programs in Java and OOP1. Now we're talking about basically putting in solutions. We're talking about how do we design it, not just how do we build it, but how do we design it for more effectiveness. Positions within the course, builds on generics, collection behavior, prepares you for parallel processing concerns and concurrency, reactive and event-driven designs, frameworks that rely heavily on functional constructs. All of these, which you will have a very good understanding on when you'll be using them, when should you consider them, and when you should not. Okay, week 4. Okay, in week 4, we're basically looking at exception architecture, logging, application robustness. This usually focuses on building resilient applications through disciplined exception handling. Make sure that we have all exceptions handled to where we fail. If we're going to fail gracefully. Okay, so that's what our concentration on here is going to be, expanding that processing as far as capturing things that might go wrong. Where, we had the try catch. We're going to go and expound on that. The unit explores strategic use of checked and unchecked exceptions in large-scale systems, emphasizing application program interface design, responsible boundaries and long-term maintainability. You will analyze how exception choices affect control flow, debugging, and system reliability. Depending on how you determine that you want to handle an error is going to affect how your program is going to work. So we're going to look at those alternatives. In parallel, students are introduced to logging and first-class design concern. Framework support, observability, diagnostics. The unit reinforces safe resource management using the try with. We're going to, again, if we're going to fail, we're going to want to fail gracefully, and that's what's going to be the concentration of this particular week 4. So we're going to be looking at design custom exception hierarchies, differentiate and apply checked and unchecked exception strategy. We don't necessarily have to check everything that possibly could go wrong. So here we're going to talk about what is that strategy that will be the best of both worlds, to where we have things that need to be checked, and things that they may be able to get away with. We may not check them. Apply defensive programming principles, use Java logging frameworks effectively, implement robust resource management, design fail-safe modular subsystems, and analyze error handling and anti-patterns. We'll get into what that means. Builds on functional and stream-based pipelines, collection-heavy and modular designs. Prepares you for concurrent and multi-threaded systems. Again, where I have 10 things going on at one time. Each one represents a thread that I'm going down. This, in essence, prepares you for being able to implement threads. Production grade logging and monitoring practices, and capstone project and robustness requirements. And we'll be talking about that. That's basically some of the information that we're putting in for week 7 when you build your final deliverable. Okay, in week 5, what we're going to jump into, it's going to introduce you to object-oriented design patterns and as reasonable solutions to recurring design patterns. What that is just saying that there are some design patterns that we can use, that if I'm in this situation, I can use these object-oriented design patterns. If I'm in this particular situation, I can use another set. So this is basically saying, when can I use a pattern? When do I need to use pattern A versus pattern B versus pattern C? Okay, so we're going to examine creational, structural, and behavioral patterns. We're going to here focusing not only on implementation mechanics, but we're going to talk about the intent, what the trade-offs are, what the design consequences are. Rather than treating patterns as recipes, this unit emphasizes pattern recognition and justification, understanding why a pattern is appropriate in a given situation and context, which is basically what I just said. A little different rewording. When is introduction necessary, unnecessarily complex? You're going to analyze how patterns interact with Java language features, such as interfaces, the abstract classes, which we kind of covered in the last class, composition, and generics. Units also enforces solid principles as framework for evaluating object-oriented designs and determine when to favor composition over inheritance. We're going to talk about what is composition and why would we want to use that instead of inheriting. By the end of the unit, you'll be able to reason about architecture of a system at a system level and applying patterns judiciously. So basically looking at what the system needs to do. How is that going to drive how I put the system together? So we're looking at our objectives of identifying, applying creational design patterns, apply structural design patterns, apply behavior design patterns, evaluate inheritance versus composition, which we stated above, apply solid principles. We'll get into deep. What is that and how does it work? Recognize design patterns, misuse, communicate architectural intent. Okay, we're just going to build on generics, reusable APIs, collection-driven systems, functional pipelines, robust error handling. And it's going to prepare you, again, you're moving it from small applications to large-scale application architecture. And using frameworks and library development. Again, project design, we're going to pick up some things that basically we'll be utilizing in week 7. Professional code reviews and technical interviews. We'll be talking about a little bit about that. But again, in the context of the project, the entire project itself that you'll be doing. Okay, week 6 is going to be our last, I guess you could say, lecture-based week, where we actually be doing homework and assignments and projects and all that good stuff, because we'll basically be, you'll see later, using week 7 to get ready for that final project presentation. Okay, so this introduces you to concurrent and asynchronous programming in Java and how object-oriented designs behave under parallel execution. You'll be able to explore multiple threads interactions with a shared state, why concurrence bugs often are subtle and dangerous, and how disciplined design prevents race conditions, deadlocks, and consistently will know and kind of understand what each one of those are and how concurrent and asynchronously processing, how is it going to affect our decisions. The shooter begins with the Java core threading model. We'll talk about that. Students will analyze using thread safety as design concerns. Be talking about behavior design patterns, kind of a little more deep dive into that. The concept of an observer, a strategy, a state, a command. We'll be looking into that and how that's applied in object-oriented programming. The unit also introduces asynchronous programming concepts. By the end of the unit, you will be able to design thread-safe, scalable, and responsive Java applications. So things we're going to be concentrating on: explaining Java's concurrency model, creating managed threads, applying synchronization and thread safety techniques, design thread-safe object-oriented systems, applying behavior design and patterns to concurrent systems, reason about common concurrency hazards, introduction to asynchronous programming concepts, and evaluate concurrent trainings. Again, right now it might seem kind of overwhelming, but it won't be. I mean, you'll be getting this pretty easy. Once we introduce the concept and you see how everything fits together, you'll see that they're more pieces of a puzzle than actually designing the puzzle itself. You're putting together with the various libraries and models, basically be saying, here's the way to do it, and you'll be plugging in pieces based on what you would like your system to do. Okay, so again, this is going to be the final week that you'll have assignment, Cornell Notes, Project Lab, and quiz. In week seven will, in its entirety, be used for you to get ready for your final project deliverables. Again, we won't really be, other than we'll be concentrating on the project. I will show you just so you'll have an idea. Okay. Some of you are going to see this twice because some of you are taking the two classes that I am teaching, which is scripting and then advanced object-oriented programming. So you're going to see this twice, but it's actually going to be different for each class as far as what the requirements are. But I will be giving you requirements, okay, as far as what I'm expecting in the final project deliverables. That is what you'll be concentrating on in week 7, is putting these together into a formal presentation of the project. Now, one thing I didn't mention, though, and I'm going back here real quick. And again, you'll see this again when I look, especially when I start going into week 1. But there is a project associated that everyone is going to be using the same project. But what you'll be doing in that is that you'll be basically feeding off of each other if there's any questions, but everyone will be required to submit their own project along with probably, yeah, the thing I do is I'm going to require you to do a demo. And that's where I'm really looking at to see that you understand what you have been written, that you wrote in your project. So, but there'll be other instances where I'm going to just kind of pinpoint to say, okay, yeah, I know everybody's using the same project, but I'd be looking for where there might have been copying, which I don't think that I will have to worry about with this class. Okay. But just wanted to let you know the project labs that we're doing each week are based on everyone basically will be doing the same project, but in somewhat of a different manner. Okay, so that's kind of the overview. I know that you looked at that and you said, wow, there's a lot there. Okay. This is an advanced class. Okay, this is an advanced class. And I haven't seen any indication that you won't be able to do it. Basically, building off the concepts that you had for object-oriented programming and taking that information and now, getting away from we're programming a Java program, okay, to we're looking at the implications of how does that affect a system? Okay, I'm writing a Java system. And what are the other considerations I'm going to need to look at? Okay, so that's going to be the overview. Please, I will kind of remind everybody else again to take a look at this particular video. We will have individual videos for each week to kind of do the deep dive into what we kind of highlighted for the unit. And I'm looking forward to seeing each and every one of you starting March 9th. Really, March 10th is when this class is going to be. But looking forward to it. We're going to have a great time, I'm sure. Everybody take it good and take it light. I will see you later. Bye.